Hey guys, welcome to my new video. In this video, we'll be discussing about derivation of banked roads. So let's consider a banked road on which a car is moving in a circular motion. So this is banking angle, that is B. The forces acting on the car are normal, weight and the frictional force respectively. And we know that centripetal force is acting radially inwards. Now let's resolve this friction force. If we resolve this force, we'll get two components like this shown in the figure. So now let's try to find out which one is the horizontal and which one is the vertical component. From mathematics we know that congruent angles are equal. So therefore we can write this angle as B. And now from the physics we came to know that the component which is making angle with the resultant is the horizontal component. And therefore we can say F cos B. And the remained component will be vertical component, that is named as F sin B. So this is a resolution of friction force. Now let's resolve normal force. Now let's try to do it separately by taking normal force. So it can be divided into two components. One is horizontal and vertical respectively. Here the component which is making small angle with the resultant will be taken as the horizontal component. Therefore, we can write the magnitude of it as n cos b, and the remaining component will be vertical component, and that can be taken as n sin b. Now by combining these two, we'll get the final diagram. Here, there are two components acting radially inwards. One is n sin b and f cos b. So by combining these two, we'll get mv square divided by r. Consider this as equation number 1. Since we know that sum of upward forces is equals to sum of downward forces, we can write n cos b is equals to w plus f sin b. And we know that w is equals to mg. By substituting that, we'll get this equation. Now by rearranging this equation, we'll get n cos b minus f sin b is equals to mg. Consider this as equation number 2. Now let's divide equation number 1 by equation number 2. So we'll get expression like this. Here m and m get cancels, which will leads to this expression. Now we know that f is equals to mu into n. Substitute that in our equation, we'll get this equation. And by taking n common and cancelling this, we'll get this equation. Now by dividing cos b in denominator and numerator, we'll get expression like this. And we know that sin b by cos b is equals to tan b. Now if we write this equation for v, we will get v is equals to root over rg of tan b plus mu divided by 1 minus mu tan b. This is the expression for velocity. Now let's try to find out banking angle. So we know that at maximum velocity mu is equals to 0. Substituting this condition in the above equation, we will get v is equals to root over rg into tan b. Now take square on both sides. We will get v square is equals to rg tan b. Now write the expression in terms of tan b, that is equals to v square divided by rg. Now take tan inverse on both sides. In the left hand side, tan inverse and tan get cancels, and we will get b is equals to tan inverse of v square divided by rg. So this is the expression for banking angle. So this is about the derivation. If you have any queries, please join my Telegram channel, and the link is in description and also in the comment box. And also don't forget to subscribe Learn with Sid. Thank you.